Hi everyone, Kurt with Hypnodyne again. We're going to take a look very briefly at a new night acquired with AirMax, our nasal sensor. And this night is pretty horrible. We can see here on the white marker track that there are flat lines in the breathing signal all throughout the night. They barely stop, only from here to roughly here do they stop, and the SpO2 is sort of constant. But other than that, we have non-stop drops in respiration and the SpO2 signal. And you can see here, one of the interesting things that I noticed in this recording is the heart was quite involved, even compared to other nights from the same subject. Every time that there's a recovery from an apnea, the heart rate goes up, and this is why having sleep apnea is so detrimental to your heart's health, because it's getting a workout for, what are we looking at here? 6:30 in the morning is when he woke up. He went to bed at 11:20. So it's 7 hours of constant heart workup. Now, if I set a range here, it's going to tell me the delta in beats per minute. So this is 20 BPM. So we go, for example, in this particular location, we go from 55 BPM up to 70 and even 75 BPM, precisely after the apnea. So if I scroll through the signal, if you look at the red signal, which is the beats per minute, you can see that here with normal respiration, the heart rate is pretty much constant. But as soon as the breathing interruptions resume, every time that the breathing interruption ends, there's a sharp spike in heart activity. If we measure here, it's plus 17 BPM, plus 16, and there's worse than that. And it goes on and on and on. So this cannot be good for you, and that's why it's important to have early screening for this type of thing. A lot of people don't know that this is going on. This subject doesn't particularly know that the situation is this grave. He was vaguely aware that maybe he has sleep apnea out of, randomly waking up in the middle of the night. But even that, these are very rare episodes, and he didn't know. But once you measure, you see that the situation can be dire indeed. Plus 18 BPM, plus 14 BPM. It just keeps going and going until he wakes up. Now, the other thing that I wanted to show today was that now in our app, this is the mobile app, and we're able to see a lot of the same information without having to transfer the file to a computer. This is a scatter chart that is showing you the length of the breathing interruption and the change in oxygen saturation, the SpO2 value. One thing that is particular to AirMax, because it's a real-time system, is that it uses a window which is configurable, but it's preset to 5 seconds. So 5 seconds is how long it takes to detect that there's a flat line in the respiration signal. These durations are expressed as an increment or a delta after the 5 seconds. So for example, if you look at this, so let's say it's 27 seconds, 28, but you have to add those 5 seconds. So it's actually really 32 seconds in length. And the reason I don't just add 5 seconds and spare you the effort of mentally calculating is because that is actually configurable. And so for now, it doesn't seem like there's going to be a need for people to configure it, but because it is configurable, then I just calculate the offset. So 5 is when it starts, and you can see there are a lot of apneas that last less than 3 seconds. They're right about at the 0 mark. The 0 mark means, remember, add 5 seconds, so these would be 5-second apneas, but the SpO2 does not go down by much at all. And we can take a look at some of them, then we'll cover the rest of the charts. So just navigate, you can click here and find one of the blue lines. Blue lines are apneas that are not so severe. So for example, here there is definitely some problem with the respiration signal dimming and fading out. But there's only a 2.8 difference in the oximetry. I'll try to find another example. This is a sort of big one. This is 20 plus 5 is 25 seconds with a 6-point drop. But you'll find many tiny ones. This is 5.2 drop, -4, -4, -3. Okay, they like this one. So this one is after the detection, which takes 5 seconds, it lasted 2.4 seconds. So this is a 7.4 second interruption in the breathing signal. And the SpO2 was not really affected much at all. You see a dip here, that's from the next one. So you can scroll and go to the next one. And this one did cause a 2.4. The interesting part is that once you're in this state, they just keep coming and coming. We've seen in the previous video that once you apply stimulation, and I should make clear, this is a night that has no stimulation. So it's we're trying to get a baseline and then add the stimulation in and see what the difference is. So this is all no stimulation. What you see on the mobile phone is an abstract, so it only shows the SpO2 signal when there is a flat line condition. So this straight line, it doesn't mean that it didn't calculate anything. It just means that this part of the signal is not shown because we're trying to keep the app as light as possible as well. We do show another signal, which is the accelerometer signal. This helps when you want to see stimulation. Let me show you what that looks like, because that was a night without stimulation. So if you move to a stimulation, here you can see the markers corresponding to the stimulation. This is sham stimulation, so you don't see anything on the accelerometer. There is no vibration. But if you do have a vibration, you see these vertical lines here. This is a true, not sham stimulation happening here and here. The difference is, well, here the stimulation happened and the breathing resumed immediately, sparing possibly a larger apnea. The desaturation was only 2.1 when the stimulation occurred. If you move into the sham region, here you will see many stimulations simply because this is sham, so there was no actual vibration. And what you expect from an apnea of this length is 27 plus 5 seconds, 32 seconds, so minus 4.6 saturation drop. And these are just more examples of roughly the same thing. You see an actual stimulation, not a sham, because on the accelerometer you see the vertical spike. So this is how you can browse through that. But we come back to our night that we're looking at. And so, okay, so we've gone through the accelerometer signal. You can choose to high pass filter it and not high pass filter it. What's the difference? If you high pass filter it, it's just going to show you spikes when there's instantaneous movement, whether it's stimulation, which we don't have here, or a sudden body movement. If you turn off the high pass filter, you can see more the original shape of the accelerometric signal. And you can see, for example, a slight change in body position here happening over a few seconds. But that's not important. The other important thing is these two polar charts. So it's showing you that this is what you're going to see most of the time on the left, which is you have to be horizontal and therefore sleeping for the apneas to occur. So all the apneas are occurring when you're horizontal, facing up. But then as far as the head position, you see that in this case, for this subject, we've already seen it in his other recordings, that it doesn't really matter the orientation of his head. Whether he's leaning slightly to the left or all the way to the right, which were the two predominant positions in this particular recording, the apneas are coming anyway. If anything, you could perhaps surmise that they're a little bit more intense when he is more facing towards up, because there are some very bright red dots over here that I'm not seeing on the right. So perhaps sleeping with the head tilted to the right is a little bit preferable to having it in this almost upright position, but not by much. So that's all I wanted to show you today. It's quite handy because up until now you've had to transfer signals to your Windows PC and then use the app HD Recorder, which is this app over here, to get readings and analyze the signal. This is still useful in many ways. For example, you can run the apnea calculation on an existing signal, changing the parameters to get the best fit for your particular setup or your particular pattern, or maybe the intensity of the breathing signal in your particular case, how you wear the device. So it's interesting to experiment, but with this new system, the new version of the app, you won't have to. Once you have all your numbers or your calibration parameters set up, you can just then record, and just by looking at your mobile phone in the morning, you can inspect and see what went on throughout the night. Now, do you have to look at all this complex stuff? Not really. If you just look at this, this is an overview of where the desaturations occurred and how intense the episodes or the events were. For the color, it's using both the length and the desaturation, but you can see that it's basically a continuous night full of events, and in these particular 3 regions, they were more bright in color, so more serious in these regions. It's interesting to compare the color here with the head position chart over here. The head position is this white line here, and you see that there's a brief episode here where the head is tilted almost all the way up, and then it occurs again over here and then over here. That roughly corresponds to the bright lines, but again, it's a very tenuous association in this case. I fully expect that there are going to be people for whom it makes a lot more difference what the head position is. And so, for example, people for whom, if you are leaning on your side and facing in one direction, then you would not have events very frequently, but if you're facing mostly upwards, then you would have more. And it could also be the opposite. Future versions of the app are going to have another feature that allows you to not even wait for the interruption, but just simply when you get into that wrong position that you're trying to avoid, that you can configure and say, this position gives me a lot more problems with breathing, then it's just going to stimulate you without waiting for the apnea. But I don't know how useful that's going to be, because after all, we can stimulate almost immediately after the problem begins. So it's more like a user awareness thing. To if you wake up and you just had a vibration, you know that you want to turn into a position that you've decided is better for your breathing. Okay, that's all I have for today. Thanks for watching, and have a good rest of your day.